let's write it down. What we can do is we know that the determinant of A equals to determinant of A inverse equals to 1 over A determinant, right? So use this property, we can write this term as, we can put the minor sign here into here. So this term is equivalent to 1 over 2 log sigma k inverse. Okay, let's do it. This guy equals to 1 over 2 log 1 over sigma k. Determinant, right? We put the minus sign into the log, and this guy equals to 1 over 2 log sigma k inverse determinant. So now we have unified these two things, and they are both divided over sigma k inverse. So we can take the derivative, instead of taking the derivative over sigma k, we can take the derivative with respect to sigma k inverse. And this guy, here is another property, log determinant A. If you take the derivative of it with respect to A, it will give you A inverse. So we can use this property to do it for this term. It will become log sigma k. And the second term is natural. It's xi minus mu k minus I minus mu k transpose. And also there are some constant terms here, so I omitted. And you send this derivative to 0, and you will get an equation of sigma k. So here is the trick for the covariance matrix estimation. And pi k is very simple. Any questions? This one? Yeah. Okay. So we have a property that if you take the derivative of log A determinant with respect to A, will give you A inverse, right? So using this guy, we take the derivative of this term with respect to phi sigma k inverse, will give us 1 over 2 sigma k, right? And for this one, it's x transpose A x. If you take the derivative of A, will give you x transpose. So using this property, this term phi sigma k inverse becomes xi minus mu k transpose. Xi minus mu k is x here, and you using this property and give you this one. Any other questions? And it's very clear that on this book, the chapter 9, 2 and 3 gives a very clear explanation of all of these things. You can refer to these 2 chapters for details. Okay, this is for today. For what? Yes, of course. So again, this function, if you take the derivative of pi k, is simply 1 over pi k. The only term involving pi k is this guy, 1 over pi k, and multiply something. And remember that there is a constraint, small k to capital K, pi k equals to 1. So you need to use this constraint. Yes.